Hello and welcome to another podcast edition of Taiwan Talk. I'm Keith Menconi. The next 12 months or so have a lot in store for Taiwan. Getting a new president. Of course, we've got some new cross-strait controversies to work out. Probably got some typhoons in the mix there somewhere as well. Well, we can add to that list the launching of two state-of-the-art satellites. Those are the Formosat 5, which will carry an optical remote sensing instrument, as the papers are calling it, that was completely designed and developed by Taiwan. Made in Taiwan, MIT, right there. That's set to launch in June. And then set to launch early next year is Formosat 7. That's a weather satellite jointly produced by Taiwan and the U.S. Got a little bit of that international cooperation thing going there. So to learn more about these satellites and Taiwan's space program, something that has been going on for a while, but we really don't talk about that much, I recently spoke with the Director of Taiwan's National Space Organization, Chang Kuei-Hsiang. Now, these Formosats, the 5 and the 7, they're actually going up to replace earlier aging satellite projects that are kind of on their way out. So there is some history here, and Chang started off our conversation by telling me about that history.
Taiwan's space program is initiated in 1991. We call long-term national space program development plan, 15 years for each. In the first phase, we are pretty focused on establish our infrastructure including like manpower, like a facility. So most of our program in the first phases is to establish our own capability because we are starting from scratch.
Just getting warmed up.
Right. So after 15 years, turn to the second phase. So that's why this is the outcome of the second phase. We are moving our focus to using our local capabilities or our local technologies to build our satellite by ourselves. So that's why we have Formosat 5 and Formosat 7 are going to launch by next 12 months.
Right, and so let's split these two up and just kind of treat the two projects a little bit separately for a second. And let's start with Formosat 5, and I think that what you just hit on right there is the really interesting thing about that one is this is a satellite that Taiwan has really developed on its own. So tell us a little bit about that.
Okay. Actually, about Formosat 2. Formosat 2 actually has a very good outcome from that program because that's provided a lot of we call disaster support to not only for Taiwan but also for all the country in the world in case have any disaster happens. Okay.
For example, I think I read that after the Fukushima disaster, you provided some of the most detailed imagery from space of what the conditions were like on the ground.
Yes, also with free charges. Okay. Most of people know Taiwanese provide a lot of donation to Japan.
Right.
Still right now, Japanese also appreciates Taiwan's support during the Fukushima's earthquake and tsunami. But you probably don't know, NSPO also provide the Formosat 2 resources to Japan governments for almost, 2 weeks. Every day we provide the data to the Japanese government for their rescue and also assess the aftermath of the tsunami. The satellite image is very useful for broad areas monitoring instead of local area. So this is one of contribution from our program. Therefore, I think the Earth observation in terms of civilian use is very helpful, especially, Taiwan has a lot of natural disaster happening in Taiwan. So we think the Earth observation is one important mission that fulfills the national needs in Taiwan. Therefore, Formosat 2 actually we cooperate with the French company. Okay, that one actually not 100% Taiwan technologies. Therefore, after the Formosat 2, we try to build can we use our own technologies, also introduce some, the local industry strengths to build the satellite by ourselves. Okay, so this is the strategy for Formosat 5. We are going to launch. I think it's by the end of June. Right?
Very exciting there. And tell our listeners a little bit, what will be the focus of the mission of Formosat 5?
Formosat 5 has actually two missions. One is, I just mentioned, we call Earth observation. Actually, we take the picture from the space. And actually, not taking Taiwan's only, we taking all over the world. Okay. And second, because...
And that's actually an important point. You cooperate with dozens and dozens of other countries and researchers all around the world. You provide this information.
Right. Not only for the disaster usage, we only provide free data for the such as science researches as well. Okay. And the Formosat 5 will be almost the same as the Formosat 2, but that is Formosat 5 as MIT. That's very important. Okay. And we build we call huge camera in the space.
Yeah.
Actually, we do it 100% in Taiwan. We design and also integration, assembly, manufacturing, and testing in Taiwan. So I could not say it's already 100% success, but we are looking forward to that.
Well, I mean, it is space technology after all, so I'm sure a certain amount of precision is in play here, we would hope. All right, well, so that gives us some of a sense of what's going to be going up on Formosat 5, hopefully in June. Let's move on to Formosat 7. Now, this is something that you're hoping to launch sometime next year, hopefully early next year. And this is going to be more focused on atmospheric monitoring, weather monitoring.
Okay, this one is also the follow-on program. It's the other program we call Formosat 3. We are going to complete the 10 years operation by April. It's actually the next month.
You're bringing
10 years
10
operation.
Years. And it was only supposed to be up for 5 years, is that right?
Actually, it's 2 years. Doing our design is a mission life we call 2 years.
Oh, wow.
Yes.
So
now
we far exceeded that.
Far exceeded that. So now become the originally we can provide around 2,000 data profiles per day.
Wow.
Right now, because of aging, because this satellite actually is a machine, a huge machine. They also have the battery problem, power problem. Yeah. And right now we dropped to around 800 data points per day.
And so that would basically snapshots that it's taking of the atmospheric conditions?
No, it's not a snapshot. Actually, we call radio occultation technologies.
Okay.
Let me try to explain not so scientifically.
Okay? All right.
Actually, for the light, electromagnetic is like a light as well. Okay. Actually, the light when they travel in the vacuum space, that should be a straight light. Okay. However, when they have some different material with different densities, such as Earth's atmosphere, okay, they will produce reflection effect on the atmosphere.
Yeah.
Okay. So we're using the GPS signal. When in the vacuum, this is our satellite, this is GPS. When it's out of our atmosphere, and what they receive GPS signal will go straight to our satellite. However, they get into the atmosphere, they will produce the bending angle. This is one of the examples is you put the chopsticks into the water, into a glasses with water, you will see a reflection images.
Right.
Exact the same thing. But the scientists, from this bending angle, they can retrieve temperature, water vapor, and also the pressure from that bending angle. That's two science, okay?
So
I don't know either how can you retrieve that, okay?
More than a snapshot, it gives all kinds of data about broad areas of the atmosphere.
I think 2 points is very important. First one, they provide the vertical profile because satellite when they get into the Earth, and they were moving very fast, so they can I think the radio frequency when they pass through atmosphere from top to down, and they will provide a vertical profile. That's very important. And second one is this is very important for the weather prediction. Okay, However, currently weather prediction, you know how to take the data for the weather prediction. They're using the sounding balloon. Okay, but used to the sounding balloon is in the place with the people living, you know. So currently only have 9,000 stations according to our data. 900 ground station. That's through international cooperation. The framework to provide the data to all the weather prediction agencies. But you know, satellite we can provide the data is in the ocean, specifically is the ocean area, also in the polar area. So that is very few ground stations that can measure the data. So the Formosat 3 have been praised as most stable and accurate thermometer in the space. So that's very important. So very significant, right?
So it fills in some of those gaps that those other stations can't provide data for.
Right.
And the significant thing for this new one that's going to be going up, the Formosat 7, is it kind of builds on what the Formosat 3 was able to do. It's you mentioned a second ago, Formosat 3 could take 2,000 of those, not snapshots, data collections per day. This next one's going to get even more than that.
Yes. If we complete deploy toward the 12 satellites in 2 clusters, and according to our simulation, we can provide more than 8,000 profile per day.
So that basically just means more detail?
Yeah, that's more detail, more dense, and the more timely. In terms of the time, we call the time resolution is much better.
I see.
Because there's more data.
And so, sticking with this specific project, what would you say is the main breakthrough or significance for, just when you think of the work that's gone into it and what your agency is getting out of it, what Taiwan will get out of it? What's the main significance of this project?
This project, I think, the very important is we adopt we call full and open data policies. Okay, we provide as a global member as a member of global villages. I think because this program, as I explained, this program is international cooperation between Taiwan and U.S.
Right, that's an important point to make.
Yes, we share the work. Okay, we share the work to complete the whole satellite development. Okay, so I think very significant because Formosat 3 is agent, or we call decades. So none of the system can provide the same data as a Formosat did. Okay, so therefore they will produce some data gaps. If we didn't have the follow-on mission to replace the old one. So this is first one. And second one is we increasing the capability of satellite. They can gather in more data, more powerful, and more mission life. Okay, so I think this is very true important focus on this program.
And tell our listeners a little bit more. You just mentioned that a second ago, the cooperation with the U.S. and NASA. Tell us a little bit more about what that cooperation has been like and what's come out of it.
This program is based on, we have some we call work breakdowns. Okay, we have signed an agreement. We call AIT TECRA agreement. Actually, it's a government-to-government agreement between Taiwan and the U.S. And for example, in the first 6 clusters, and the U.S. provided launch vehicles. Okay, and they provide the major payloads and also the science payloads, and also the global ground tracking station. And in Taiwan, actually, it's NSPO. We provide all the system engineering work, including the design and also integration and test, and also provide the mission operation and data processing in Taiwan. That's constitute the whole systems. So actually, finally, the operation will be in Taiwan, and data will be distributed from Taiwan and to the U.S. and to the global users as well. Right.
And this is pretty interesting because something that you've spoken about before in the media is just the fact that it can be difficult for space technology to be accessible to Taiwan because of the international political situation, and so is this cooperation with the United States, is it helpful to get past that?
Actually, in this program, we don't have any technology transfer in this program because that's for civilian use.
I see.
Okay, you are very understand the space industry very well, and actually, space technology has some characteristic. Okay, and the first one is a very sensitive technologies.
Right. Because there's always a military application.
Right. Always has some military application. Therefore, I think the Taiwan space program, initially we have, our program from Formosa 1 to Formosa 7. Mm-hmm. We are all doing in the civilian use purpose, such as disaster support, such as meteorological satellites. Mm-hmm. So I could not say there is no useful for military purpose. But I think this is the strategy of Taiwan. So that will be, I think this would very, as we say, this is all peaceful use purpose. Right?
That is the focus. So help our listeners understand. I mean, obviously, I think that the work that you guys are doing does not get we don't hear about it as much as we probably should, and so we probably are not thinking enough about why this is significant. So give us a sense of, beyond the obvious direct applications that we've already discussed, what these satellites are going to be doing. Beyond that, what is the broader significance of putting stuff into space and getting better at space technology?
I think every countries they think about. I always explain that most significant theory or more important event. For example, Newton's gravitation. They discovered the gravitation forces, all from the interest about the space. Mm-hmm. So I think the space is the source. Mm-hmm. If you want to discover the new science or new technologies. So I think space program is a very good, driver program for one countries or nations. They want to promote, one is we call system learning, because this is very complicated system, including a lot of interdiscipline in this program. And second one is, in the space environment is quite different as the environment on the ground. For example, you using the computer in front of you, maybe 30,000 Taiwanese dollars. Right? Mm-hmm. That would maybe, I think it's 300 million in the space. But function even worse than using this here. But so this is the others advance of your industry competence. How do you upgrade your quality, reliability on each component of instrument you are going to put in the space. And also because satellite once is launched into the orbit, can you fix that? No. Some maybe the U.S. can do have space shuttle that can fix that, but that's too costly.
Yeah.
So we have to pursue very high we call reliability on this system. So I think all this kind of workmanship or know-how, they can feed back to our industries. So I think that's very, from my personal point of view, perspective, I think that's a very important factor. Why for small country, or even now has many countries like Vietnam, like Thailand, they spend a lot of resources in space program. Right.
And so basically the bottom line is this kind of research pushes every kind of research, every kind of science and engineering forward.
Right. Very important is we call not only for the science perspective, from engineering perspective, you need a lot of we call interdiscipline. So you have to cooperate with different fields. For example, we need a lot of expertise, communication, thermal, structure, not only electronics, but the electronics, mechanical, also the software as well. So my challenge is how to make an environment that is different expertise engineering. They work together to build one thing. This is my challenge.
Wow. A lot of stuff to bring together.
Right.
So would you say that at this point Taiwan has developed a reputation in space research among other countries? I mean, obviously it doesn't have the resources of Russia or the United States, but are there some ways in which Taiwan is regarded as being capable in this area?
I think in space technology, from my personal perspective, should be internationally instead of local, because satellite, they are orbiting around the Earth, around everywhere globally, instead of only focusing Taiwan. So when we initiate the space program, has a lot of controversy on this argument. It's why we have spent so much money to develop this space program, but Taiwan only used very few the portion of the satellite operations times. I think as I mentioned earlier, I think space program is the driver for the not only for economics, but also for the industry. But other countries they use also in diplomas and also politics. There are lots of politics and diplomat implication in the space program. Okay. So I try to persuade my bosses is space program you cannot see is just a R&D program. That's just only R&D program. We have to leverage the space program into the national need, not only on the technology development, but also for the economics, but also for the sustainable Taiwan. I think that's a very important purpose. Because we have lots of data, we can support the sustainable Taiwan, such as disaster monitoring as well, and also the weather satellite. And second one, they can also use as the diplomer leverage, the diplomer powers. Okay, you can because we use this data, we can support free data to Japan, even for the mainland China, we did as well when the Sichuan earthquake. So this kind would be good to help the country or your nation maintain the I think is diplomatic relationships with other foreigners. So this is we call it multi-purpose uses. Not only for technology development.
Right. So I hate this term. People use it too much, but I guess here it's very appropriate. In a way, it's a form of soft power. It's a way of increasing Taiwan's international standing,
visibility, and also humanity. So I think that's very important for Taiwan reputation. And I think, Taiwan current political situation is pretty difficult or challenges. I think we can leverage space program into this kind of, I think, different perspectives, right?
All right. So we do have a lot coming up in the next year. So one last time, just remind our listeners, June is going to be a very tense time. So remind our listeners, when are these satellites expected to be launched?
We are going to launch, currently we tentative, actually no changes at this moment. We target for June 28th in U.S. time, but that will be early, I think the midline in 29th June in Taiwan. Okay.
And that's Formosat 5, and it'll be launching off from California?
Yes, from Vandenberg Space Air Force.
All right. Right. And so this will be a very tense time for you.
Of course, we're pretty busy because we have to shift our satellites from Taiwan to U.S. Also very sophisticated work. A lot of tedious. We have to make sure we can safely shift our satellite into the launch site and check the satellite is okay. And also we have to make sure we have the right mapping or interfaces with the launch vehicle.
So when do you get to relax? Like, is it once it's off the launch pad? Is it once it's in orbit? Is it once it's sending data back? When do you actually get to go, it worked?
Thank you. You asked me this question. This is very important. I try to explain this. Just launch is not 100% success of your mission, okay? Once the launch, first we have established the communication link with the satellite. That's the first point. After launch, you have to make sure we can communicate, we can talk to the satellite, such that we can know the satellite is still very healthy or functioning, doing okay during the launch environment. That's the first thing. And second one, we're going to check all these, we call the instruments, and also the spacecraft itself, if everything is function as expected. That's the second very important. That takes about a week to check all the functions. Okay. And that with last one, with you have to turn on your instrument. That's just, the instrument they use to take the data, the mission data for you. We have to make sure we take the right data as you designed it. So we have a lot of, threshold we have to break through. Okay, so successful launch, only 1/3 of the, all the launch campaign, 1/3 of that. Again, I appreciate you asking me this question. I think this is very important for the audience. Okay.
So probably you're going to be waiting till about July before you can really sit back, relax, pop the champagne, and celebrate.
I think the celebration that's on I think the end of July. We will see. Man. Yes.
All right. Very nerve-wracking job. We all are going to have our fingers crossed for you. We have been speaking today to Chang Kuei-Hsiang. He is the Director General of Taiwan's National Space Organization. Kuei-Hsiang, thank you so much for speaking with us today.
Thank you. This is my very enjoyable time with talking with you. Thank you.
Thanks for listening to another podcast edition of Taiwan Talk. Taiwan Talk is, of course, ICRT's interview program, bringing you conversations from and about Taiwan. Please do leave a comment on our blog or rate and review the show on iTunes. Really does help other people find out about the program. We appreciate that a whole bunch. And if you're looking for updates on Taiwan Talk and other stuff from ICRT, you can, of course, follow us on Twitter. We tweet at ICRT News for our news-related tweets and at ICRT100 for our programming-related tweets. Or you can follow me at Keith Benconi for, me-related tweets. That is it for the show today. Thank you once again for listening in. For ICRT and Taiwan Talk, I'm Keith Benconi. See you next time.